My name is Zaid Aviles, and I'll be solving problem number 3. So, we're going to find the volume of the solid whose base is a circular disk with a radius of 5, and parallel cross-sections perpendicular to the base are squares. So I'm going to start off by drawing a diagram of what our shape is going to look like. So from what we know is our base is going to be a circle, and the radius of our base is 5. And what we also know is that when we take slices of our shape, we're going to end up with squares. So let's say we take a slice right here of our shape, we get a square. And this diagram is a top-down view currently. So if we take the slice we just took and look at it under different perspective, it is a square. And so knowing that, we're gonna now solve for the area of one of our slices for now. So to do that, since our base is a circle, we're gonna start off with the equation of a circle, which is x squared plus y squared is equal to r squared. But from what we know, r is 5. So it's going to be 5 squared. And looking back at our diagram, we're going to turn this into a coordinate right now so we can begin solving. And so we're going to make this our x-axis and this our y-axis. And so when we look at a location on our x-axis, this is the location of one of our slices. And what we want to know is the length of one of our slices, because the length of one slice is one of the lengths of our slice. And so we're going to solve for y. So I'm going to begin by moving x squared to the other side. So we get y squared is equal to 5 squared minus x squared. And we're going to take the square root on both sides. So we're going to end up with y is equal to the square root of 5 squared minus x squared. Actually, it's going to be y is equal to plus minus the square root of 5 squared minus x squared. And going back to our diagram, I'll show you why right now. So the positive's square root is actually this area up here. And the negative square root is actually this area down here. And so if we look, they're symmetrical. So what we can actually do is we can rewrite this as y is equal to 2 square root of 5 squared minus x squared. And looking back at our diagram, this y value is actually one of the side lengths of our square. So what we can rewrite it as is 2 times the square root of 5 squared minus x squared. And since it's a square, we know that each side length is equal. So we can also write that this side length is also 5 squared minus x squared. And now we want to solve for the area of this slice. So to do that, we have to multiply the length and the height of our slice. So this is going to turn out to be 2 times the square root of 5 squared minus x squared times 2 times the square root of 5 squared minus x squared. And so I'm going to begin by taking the square root. So it's going to be 2 parenthesis 5 minus x squared times 2 parenthesis 5 minus x. I said x squared, but I'm in x. And so I'm going to leave it as this with the parenthesis, and you'll see why in a little bit. And when we multiply both sides, it's going to be 4 times parenthesis 25 minus x squared. And this is the area of one of our slices. But we want to find the volume. So to find volume, you have to take infinitely many slices. So to do that, we're actually going to use an integral. And we know that the area of one of our slices is 4 times 25 minus x squared. But now we need our bounds that we're going to evaluate with. And so we're going to look back at our diagram. And since it's a coordinate plane, we're going to know that our origin is 0, 0, and our radius is 5. So our rightmost value of our diagram is 5, and our leftmost value is -5. Because we're going to try to find the area of each slice across this entire diagram or shape. So our bounds will actually end up integrating. We're going to end up integrating from -5 to 5. And this is our integral to find the volume. And so first I'm going to take, since 4 is a constant multiple, I'm going to actually take it to the other side of our integral. This is why I left the area of our slice in this form, just to make it easier for ourselves. So now it's from -5 to 5, 25 minus x squared dx. And so now we can actually integrate from here, since it's a pretty straightforward integral. So it's going to be 4 times 25x minus x cubed over 3. And here we're just using power rule, so nothing fancy. And now we can actually start evaluating. So our bounds are -5 to 5. And I'll move down here to software. So it's gonna be 4 times 25 -5. Nope. We're gonna begin with +5, sorry. +5 minus 5 cubed over 3 bracket minus 4 times. Now it's -5. -25 times 5. I just moved the negative from the 5 to in front of the 25. They're multiplied, so it doesn't really matter. As long as you keep the negative. Minus -5 cubed over 3. And so now we just have to solve. I wrote a bracket, but parenthesis bracket, it doesn't matter as long as you remain consistent. So now it's going to be 25 times 5. That's going to be 125 minus 5 cubed is 125 over 3 minus 4. No, it's -125 minus. And since it's a cube root, we're going to end up with a negative. So it's -125 over 3. And since there are two negatives, this is just a positive. And now we're going to distribute the 4. So it's going to be 500 minus 500 over 3 minus, actually wait, no. It's going to end up being a plus, because if you see here, it's a negative we have to distribute. It's going to be plus 500, we're also distributing the 4, plus 500, distributing the negative, so this becomes a negative 500 over 3. And so now we just add like terms, so it's going to be 1,000. It's going to be 1,000 minus 1,000 over 3. And to subtract these values, we have to make sure they have the same denominator. So we're going to multiply the 1,000 by 3. So we're going to end up with 3,000 over 3 minus 1,000 over 3. And we're going to end up with 2,000, over 3. And then it's going to be units cubed. And this is a volume. So the reason why 10 is cubed, just to keep in mind, is we're solving for the volume. So you're going to end up with cubic units. And that's it.